function.
Okay, nice. Andrew, put a box around that bitch, man.
Oh yeah. Here we go.
As you have to say, if you don't put a box around it, it's not official.
It's just not
Alright.
good.
They're good.
Alright guys. So today we're going to be finding the equation of a tangent plane using the function of r uv and initial point, -1, -1, -1. And so
You
first
can
off,
put that paper down, by the way, because there's no answers. To the viewers, we don't have any
there's no
fucking answers.
Yeah,
He's doing
there's
this
no
shit live.
answers. Yeah, right away. Alright, so first off, we're going to try and find the derivative of ru respect to u. So it's going to look like this. And so derivative of u inside the I component is just going to be -2u. And then we're going to go to the j component. There's no u in there, so it's going to be 0. And then we're going to go to the k component, and it's just going to be -1. So then that's going to be that. And then we're going to do the same thing for v. So then with our I component, it's going to be -2v. Our j component is going to be -1. Our k component is going to be 0 because there's no v in the k component. Alright, so then we're going to do the cross product of ru, rv. So it's going to look like something like this. And if you have to, you can write it out like this, ijk. And then we're going to put -2u, 0, -1, and then -2v, -1, 0. And then we'll bring it down here. And then so how you do this is we're going to cross off.
Put some damn lines around that bitch, man.
So you're going to cross out the first component, and we're going to do the cross right here, so that's just going to be 0. And then we're going to go -1 times -1 is +1, but we're subtracting it still, so it's going to be 1 for the first component, for I component. And then we're going to remember to put the negative out front for the j component. And so it's going to be -2u times 0, that's just going to be 0. And then minus -1 times -2v. So then that's just going to be up to 2v. And that's going to be our j component. And then we're going to put a plus in front of the k component. And we're going to calculate our k component now. And so it's going to be -2u times -1. That's just going to be 2u. And then minus 0. And that's going to be our k component. And then it's just going to come out to be -1, 2v, and then 2u for the last component. So then this is going to be our ru times rv, or cross rv, sorry about that. So then how we're going to want to get the tangent plane at this point, -1, -1, we're going to do the dot product with this point in terms of x minus the x point of the initial point. So it's going to look like this. It'll just be x minus -1, which is going to be x plus 1, and then y plus 1, because we got -1s up here, and then z plus 1. And we're going to have to dot this with our cross product that we have here. But first, before we do that, we have to put the x, the y, and the z in terms of u and v. And we're going to use our initial equation. So the I component is going to be our x, the j component is going to be our y, and the k component is going to be our z. And so we're going to do this now. P will equal, and we got 1 minus ut minus vt plus 1 for our x in the point. And then we're going to go here. So then we have minus v plus 1. And then we're going to go to right here. And our z equals -u. So then it will be -u plus 1. All right. So then we can do a little bit of simplification right here. And it's just going to be 2 minus u squared minus u squared. Actually, that's just going to be 0. So then we could do, so it'll be 1 plus 1 is 2. Never mind, never mind. It's not 0. And that's not that. Uh-oh, I'm cracking.
You're good. Yes, that's a vector.
Yeah. So right here, this is a parenthesis.
You mean a bracket.
Huh?
You mean a bracket.
Why?
Because it's a position vector.
Yes, it is a position vector. Yes. These are brackets. That's not a vector.
I thought you meant they were brackets. They look pretty brackety.
Yeah, they do look pretty brackety.
Guys, leave a comment if those are either brackets or parentheses. I thought he was going brackets. I thought he was just a curvy bracket guy.
All right, we're set now. The brackets because it is a vector.
Yes, guys. This is P, point PO to P is a vector. It's a position vector.
Yeah. All right. So then we just have this again. Plus 1. And then minus u plus 1. All right. And that's our final vector for the P naught to P. So then we're going to do the dot product of our cross product of our u, our v, to what we just calculated here for our position vector. So it's going to be, we'll do it down here. It's going to be -1 2v 2u dotted with 2 minus u squared minus v squared, and then minus v plus 1 minus u plus 1. This is going to come out to be, we're going to have -1 times 2 is going to be -2. -1 times negative u squared is going to be positive u squared. Same goes to v squared, which is going to be plus v squared. And we're going to move on to the next component. It's going to be 2v times negative v. So it's going to be minus 2v squared. And then 2v times plus 1 is going to be plus 2v. And we're going to go on to the next component, the k component. It's going to be 2u times negative u, which is going to be 2u squared minus 2u squared. And then we're going to do the same thing, 2u times plus 1 is going to be plus 2u. And then we're just going to simplify it out. So we got u squared right here, we got minus 2u squared right there. Fix that. All right. And so that's going to be just minus u squared. Then we have v squared minus 2v squared minus v squared. And then we have 2v and 2u plus 2v plus 2u. And then final is going to be minus 2.
Okay, you're live.
All right, guys.
Sorry, the camera died.
Yep, it died. So we got this right here. This is what we got from doing the dot product between our normal vector right here and our point vector right here. And so we got to convert this into x and y. And so we're going to use...
And z.
And z, yes. And so what we're going to do is we're going to use our first components from our RUV equation vector. And so we're going to do a little bit of algebra to save this. So we're just going to rewrite this as minus u squared minus v squared, and then plus 1 minus 3, and then plus 2v plus 2u. And if you can see what's going on here, this is going to be our x. This v right here is going to be our y. But up here in this component, it's negative v, so it's just going to turn this to -2y. And so we'll say that this is all y. And then the same thing goes for here, and this is our z. So then the final answer will be written out as, it'll be equal to x minus 3 minus 2y minus 2z.
And this is all equal to what, 0, right?
Yes, it is. And so if you wanted to, you could just bring this 3 out here, and this will be your equation for your tangent plane at this point, -1, -1, -1, for this vector function.
Okay, nice. Andrew, put a box around that bitch, man.
Oh yeah, here we go.
As you know what they say, if you don't put a box around it, it's not official.
It's just not
All right.
good. It's just not fun.
Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.